Okay, hello everyone, welcome back to the relational model. In the last week, we have covered the basic information about relational model already. If you still remember, we provide the motivation why we need to use a relational model. We also provide the definition of relations for you, and we cover some basic information how to create a relation in SQL, and as well as some basic data types we can use for relation definition. And we also mention how to handle these kinds of referential integrity constraints, the keys, as well as foreign keys for you. And at the end, we also introduce how to delete, update relations in SQL as well. So you can go over the slide we have introduced in the last week before we continue to the translation. So you can see in this week, we will be mainly focused on the translation of the ER diagrams into relations. In other words, for everything we design in the last section in the ER model, we need to translate everything into relations based on the relational model. In this way, we will be able to store all the data we have into relations or into tables in our database systems. So the translation can be very important for us. For the translation, we need to translate everything, including these entities, the rectangles, the attributes, the relationships, as well as some special cases like the weakness subclass and referential integrity constraints and etc. So everything we learned before will be translated into relations. As we can see in this page, we provide some basic information already. We will go over them one by one in the following pages as well. So let's go over the basic cases first. So for the entities, if we have an entity, we need to translate it into a relation by combining all its original attributes of this entity. And given a relation, we can also do the translation by combining all the attributes of the relationships together with the keys of the related entities, which are connected to the relationship. And for some special cases, like relationships with one-to-many or one-to-one constraints, then the translation rules will be very different because we may need to combine some relations into one, which can save lots of storage space. And for the working sets, we also need to have some special rules to handle them. It will be very similar for a subclass. When we translate the is a relationship, we also need to have special rules to handle it. All this will be covered in the following pages. We can start with a very simple case about the entities we have before. So let's say in this page we show an entity. It's about the employees. So we have an employee rectangle here. This is the entity. The employee has three attributes. The first one is SSN. The second one is name. The third one is not. So for the employees, we have the SSN to be the key of the entity, right? So therefore, we have 1 on the 9 as shown here. And this is the ER diagram we drew before, right? And when we try to store some data about employees into our database systems, we cannot store the diagrams, and we have to use something like tables, right? As shown here. We have to store the data into tables with another 3 columns denoting the attributes, SSN, name, and not. Then the problem will be how can we translate this entity into a relation, right? Into a relation. So the translation is very simple. We just combine all the attributes of this entity together. It will form a new relation, right? Okay, before we show the table creation, let me provide you with the translation rules first for the entities. So given the entity, the ER diagram as shown here about the employees, we can first translate it into a relation, right? If you still remember how we represent a relation before, so if given a relation, we need to provide a relation name as well as a bunch of attributes inside it, together with some data types of these attributes, right? So next, use this one as an example, and we can show you how to do the translation for the entities. So given the ER diagram, we can translate it into a relation. The first one will be the relation name, right? It will be employees. And we can use the same name as the entity names shown here as a relation name for our new relation. Right? And we have a parentheses. Inside the parentheses, we have a bunch of attributes. Right? The first one we have is SSN. And we have a data type for it. For SSN, its length is fixed, right? And then we can use a char. chart 9 for it. Besides SSN, we also have a name. The name is also a string, right? However, the names can be very different for different person. Therefore, we can use var char. Now we can give 50 as the max name. So I hope you still remember what's the difference between char and var char. And the third one will be not. We can give a very simple data type like int. Denotes it an integer, right? And then we can translate this ER diagram into relations, as shown here. Before we move to the table creation, I have a question for you. Are we finished or not for the translation? Before we remind you, right, whenever you design a ER diagram about the entities, you need to ask yourself what is the key for the entity, right? SSN is the key for the entity. Therefore, we have a 1 on the 9 as shown here. It will be very similar for the relations. Whenever you do the translation into relations, ask yourself what is the key for the new relation you created. So for the employees, we know the SSN can be the key, right? It will also be the key for the relation. And we need to highlight this one is a key by adding 1 on the 9, right? As shown here. So the key is very important. Remind yourself when you do the translation. Then we can move to the table creation, right? In SQL based on the relation we have. So when you do your homework, you can either provide the relation as shown here, or you can provide the creation of tables. They are the same for me in my perspective, because the final target is to translate the relations and also represent the relation into tables, right? So if you can also provide answer for table creation, it will also be very good. Okay, let me copy the text so we can use the same format, the same font. So if you still remember the grammar in SQL for table creation, right? So generally we start with create table. And some students may have some question about this font. I mean, normally for the reserved words in SQL, I prefer to use this uppercase for all the phrases. Create table, they are reserved words by SQL, right? So I prefer use the uppercase. And for the names, relation names, I just write it in a normal way. Employees. It will help you differentiate different phrases in the code. So we can know the uppercase is some reserved words, the normal case is some variables or names, right? And then inside it, we need to provide some attributes. The first one is the SSN, right? We know its type is char 9. The second one is the name. We know it is var char 50. The third one is not. Its type is integer. We just write int. That's enough. So are we finished already or not for the table creation? Please allow me to remind you again. Whenever we draw a rectangle about entities, ask yourself what is the key, right, for the entity. After we do a translation into relations, ask yourself what is the key for the relation, right? Once you create a table based on a relation, ask yourself what is the key for the table, right? So therefore, we need to highlight the key for the table in the code. We can use the primary key, right? We know its key is SSN, right? And we need to highlight its key at the bottom. Then we can create a table for the employees in SQL. So I hope you can follow me, right? Given entity, we need to translate it into relations as well as provide the code in SQL. So in the homework, we will have lots of questions on this, how to do the translation. So you can either provide this one or provide this one. Both will work for me. But personally, I prefer if you can provide the create tables, or you can provide both. Because in the tables, you need to remind yourself what is the primary key. Some cases, you need to remind yourself what is the foreign key exchange, right? And it can train you the knowledge we learn from the course. Okay, so this is a table creation in SQL after we do the translation of entities into relations. Let's come back to the slides. So it covers generally the same information we show in the example, right? The given entity, when you do the translation, will highlight the primary key of the tables as shown here. Okay, this is about translation of entities. Let's move to the relationships.